Okay. Area. Who remembered it was pi r squared for the green one? Awesome, that's fantastic. I'm going to give you a radius, and I want you to just do pi r squared with it. Let's say that the radius is 8. Pi r squared, in this case then, would be pi times what? 8 squared, which is 64. 64 pi. That's the area of it. Now, some kids feel better when they put it in a calculator and multiply it out. You do not have to do that. But later, I think, for the homework, we'll probably be doing the calculator way. So you'd go, what for pi? 3.14. But did you know there was a pi button on the graphing calculators? It's a little more accurate. All right. So I'm going to project this up onto the screen. Hold on just a second. All right. For a triangle, I know everybody's got this one. It's base times height. Okay, so if this is 3 and this is 10, then it's 3 times 10 is 30. Those are a little too easy. But the triangle, a lot of people forget that when they think it's base times height again. What's the little catch? Base times height and then what? Yes? You are correct. Base times height divided by 2. I could put a 1/2 in front of base times height. Or I could say base times height and divide it by 2. Either way. All right. So, good enough on those. We're going to need them. If you really understood that, you'll be able to find the areas of these 3 things. Right now, we're not worried about units. You don't have to say like meters squared. Figure out these 3 answers to the green one, the orange one, and the red one. And then I'm going to pair you up with somebody in class to compare answers with. The first one's area was 28.27, and this one's area, 5 times 3 is 15, super easy. And then this last one is 6 times 3 is 18. I get that on the test all the time. What is it actually? 9, because you do 1/2 of the base times height. So it's 9. Raise your hand if you actually had 9. Okay, good. Now, why do we care about this? Are we in geometry class? No. But we're doing probabilities. So imagine for a moment that you had a circle in your backyard, like a target. Okay? And let's say that you are throwing ping pong balls up in the air from a long ways away. You're on a ladder and you're tossing the ping pong ball and you're trying to get it in the circle. Let's say within the circle, there's a square. And you made this game where if you get it inside the square, you win. Well, if it's truly a square, do you get that the sides are equal? And so let's say it's a 3 foot by 3 foot square. And let's say that the radius of our circle is 4 foot. That's the radius. So my question, what's the probability you're going to hit the square? Well, probability is what you want over what's possible. Have you seen me come back to that over and over and over again? So when you're stuck on the test, write it out. Go, what do I want? I want the square. How much is in the square? 9. Now I got that, 3 times 3. Over what was possible, the whole circle. And then you divide them. Use your calculator, get a final answer as a decimal, give it a shot. This problem is not on your page, so you're just going off to the side and trying it with me. You don't have to draw it perfectly. We have already got to what we want on top. Okay, Megan Peterson, looks like you arrived, but we've already started the lesson. And so for the next few minutes, you're just going to have to wait till I finish the lesson, and then I will post it. I can't stop the lesson. It's outside of the Google Meet, and I can't stop it or it'll kill the video. So hold on just a few minutes, and then we'll be done. And I'll post it for you. All right, here we go. You should have said that it was pi r squared, which is pi times 4 squared, which is 16 times pi. Did you know to take 9 divided by 16 times pi? Raise your hand if you understood that. That's what you were supposed to do. Good. Eddie, did you get a final answer as a decimal?
I got 50.27.
I think you divided wrong because it wouldn't be 50. It might have been point something, like a decimal.
Oh, I didn't do 9 divided by 16.
Okay, so first you got to put in 9, then you got to say divided by. Now, you would want to put this in parentheses. So you'd do 9 divided by, Eddie, can you type this in? Parentheses 16 times pi. I'd use the pi button on the calculator. I'll give you the most accurate answer. What do you get now?
0.18.
1.8. Can anybody verify 0.18? There we go. 18% chance that you'd hit the little box because that's 9 out of 16 pi. All right, we're going to do another one like that with this page. Do you get that the shaded region is usually the region you're trying to hit? If you haven't caught this yet, that's usually what they're doing. So figure out the area of what you want, which is the shaded, and then divide by the area of the whole thing. So if this is 7 times 5, you should have had 35, but then you take half of that. So what do you get for half of 35? I'm going to use my calculator and go 35 divided by 2, and I get 17.5. Did you agree that that was 17.5 for the big square, or the shaded? 17.5, good. 17.5 divided by the whole thing, which is not 5 times 4. It's 5 times 11, makes 55. Divided by 55, final answer, 31.8%. How many of you got 31.8? Okay, good. Then, here's one. Find the probability of the dart landing in this shaded region. Give this one a shot, and we are almost done. And I can upload that video for Megan. It's what you want over what's possible. What I want is to hit the square, and that's 9. What's possible? Pi r squared, that's pi times 10 squared, that's pi times 100. So I'd go in my calculator and go 9 divided by parentheses 100 times pi. And the parentheses, and I get 0.028. Now what the heck does that mean? Does that mean 28%? What does it mean? 2.8. You are correct. 2.8%. You always move the decimal over 2 spots. Who had the 2 and the 8? Raise your hand if you did. Okay, good. I think you're getting this. So, I think this will be overkill. I think you get the idea. You know? You keep doing these, but I feel like you're getting this. So, it's what you want, which over what's possible. Now, the shaded region this time is a little weirder. So you don't just go the circle, which is pi r squared, over the square, which is 15 times 6. It's not quite that simple, though. I want you to look it over and see, why isn't it that? Because we want the shaded region, so we're going to have to subtract the 2 to figure out what's on top. If it was about probability of landing in the circle, then this would have been right. But it's not. So how the heck do we find the shaded region when it's not inside the little shape? You take the bigger one minus the smaller one. That's what you want over what's possible. Okay, so what's the bigger one? 15 times 6. I'll save you some time and be your calculator. 15 times 6 is 90. Minus the smaller one is the circle with the radius of 1 pi r squared, which is pi times 1. 1 squared is 1. So it's really 90 minus pi. I'll use my calculator. Minus pi, and I get 86.85. I'm going to round that to 86.9. And what's possible? The whole thing. It's still 15 times 6 on the bottom. That part was right. So on this kind, where they're shaded outside of a shape, try to remember you go the bigger minus the smaller. And the final answer on this one is the 86.9 divided by the 15 times 6. I did it wrong because I didn't do the parentheses. You got to remember these parentheses here. I just screwed it up. I don't know if you did too. 86.9 divided by parentheses 15 times 6. There it is. Something's still wrong. Oh, I put in 15.6. Oh, I just typed it wrong. Sorry. 86.9 divided by 15 times 6 is 90. I already figured that out, so I can divide by 90. Finally, 0.96555. Who had it before I did? Awesome. Nice job. Okay, that's it, boys and girls. You've learned how to do it. And now it's just about the problems get more complicated looking, but it's always what you want divided by what's possible. All right, so the homework for today is, can you look for me? I think it's a worksheet, isn't it? A worksheet? Okay. Now, open that worksheet up quick, and I'm going to tell you one or two that you can skip. I try to make your homework assignments a little smaller when they're worksheets, because we tend to have a few more problems than we really need to. So I'm fine with cutting them down in size. I want you to keep doing them, so I need to keep them reasonably sized. I'm going to pause for a second while somebody pulls that up, and you can tell me, so I can look at yours, and I can tell you which ones to skip. Okay, so on today's worksheet, cross off problems 3, 5, and 7. Does that mean you can't do them? No, if you want to do them for practice, go for it. But put a big X over 3, 5, and 7, and only do them if you feel like you need to practice. Okay, another thing I like to do is post a key. I haven't posted the key yet, but later tonight, if you're like, oh, I can't get this one, go look at the key. Totally okay. In fact, I would rather have a kid look at the key than just kind of guess. It's so much smarter to take a second and make sure you understand how to do it. If all you do is copy the answer from the key, I will not give you credit. You'd have to copy all the work too. Even then, I think that's dumb to copy, but I want it there because one of the most important things to do is to tell if you're doing it right. Practicing math the wrong way is the worst, because you'll end up getting it stuck in your head that that's how you're supposed to do it. So do a couple problems, then go check the key. And that's all I got for you for the video for today.